In this video, we are going to look at dividing rational expressions. So we're going to be dividing with those fancy fractions. The good news is that if you can multiply these fancy fractions, you're going to be able to divide the fancy fractions. There's just one very important step at the beginning, and then it just becomes a multiplication problem. So when you actually divide fractions in math, it's not really a division process. It's a multiplying by the reciprocal. So let's look at what that really means. So the steps for dividing rational expressions are to rewrite as a multiplication problem. Keep, change, flip is the way I like to think about it. And this step is the key, because once you do that step, then you've changed it to a multiplication problem and you already know how to do that. So when you turn it into the multiplication problem, you factor each numerator and denominator, you cancel common factors, and then you multiply, which is the squeezing together. So again, this first step of changing it into a multiplication problem is key. And the step for doing that is to keep the first fraction just like it is, change the sign from division to multiplication, and then flip that second fraction, which is the reciprocal of it. So let's jump in and look at an example. Number 9 asks us to divide x squared minus x minus 12 over 5x by x squared minus 10x plus 24 over x squared minus 6x. So we're going to get lots of factoring practice in this problem. So remember, first step is we've got to change it from a division to a multiplication problem. Keep, change, flip. So we're going to keep the first fraction just like it is, x squared minus x minus 12 over 5x. We're going to change that division sign to a multiplication sign, and then we're going to flip the second fraction. So the second fraction now becomes x squared minus 6x over x squared minus 10x plus 24. All right, so again, we're flipping it. The numerators and the denominator are changing place. All right, now we have a multiplication problem. So I'm going to get ready to do my scratch work. I'm going to start with the first numerator, which is x squared minus x minus 12. So it's a 3-term polynomial, so I'm going to use split b. So I'm looking for factors of a times c, factors of negative 12 that give me negative 1. So that's going to be a negative 4 times negative 3, it's hard to read, sorry, is going to give me that negative 1. So negative 4x plus 3x is how I'm going to split up my b, bring down that first term and then that last term. All right, and now I can do my grouping. The GCF of the first group is an x, and when I pull out an x, I'm left with x minus 4. I'll bring down that plus. The GCF of the second group is a 3. And that leaves me with x minus 4. Those x minus 4's match. I've got x minus 4 times x plus 3. So that is the factored form of the first numerator. So x minus 4 times x plus 3. Well, 5x can't be factored anymore. You can remember that 5x really means 5 times x. It's not a unit, it's a monomial. All right, now I'm going to look at the second fraction. The numerator is x squared minus 6x. Well, 2-term polynomials, it's either GCF or it is difference of squares. So obviously it's not difference of squares, so that means it must be a GCF. So I'm going to pull out an x, and that leaves me with x minus 6. So that is my numerator, x times x minus 6. And then my denominator is the trinomial x squared minus 10x plus 24. So I'm looking for factors of a times c is 24 and b is negative 10. So sorry, it's kind of messy over here. That's what scratch work sometimes looks like. That would be a negative 4 times negative 6 is positive 24, and negative 4 plus negative 6 is negative 10. So I'll split up my b term into negative 4x and a negative 6x. All right, and now I can do my grouping. I'll pull out an x from the first group. That leaves me with x minus 4. Bring down that negative, super, super important. And the next group shares a 6, but really it's not a 6, it's a negative 6 that I'm dividing by. So that's going to flip the sign that's in front of my last term. So when I divide both terms by negative 6, I'm left with x minus 4. They match, so I've got x minus 4 times x minus 6. And then you have to take a big, deep breath and say, whew, that's a lot of work. All right, now is the rewarding part, finding those things that you can cancel. All right, so I see x minus 4s that match. That's a diagonal cancellation, and I see an x minus 6 that matches. And then this is tricky, but this x and this x down here can be canceled because the 5 and the x are multiplied together. It's not a unit. It's one term, and they are factors of each other. It's like 5 times x, just like in the numerator, it's x minus 4 times x plus 3. So I can cancel out the x's here. I know that's a little confusing. We haven't seen that yet, but we can do that because the 5 and the x are factors. It's not a unit. So now is the squeeze step. So what do I have to squeeze together? Well, in the numerator, I only have an x plus 3. And in the denominator, I only have a 5. So there's not a lot of squeezing going on there. Okay, so the quotient, which is your answer in a division problem, is x plus 3 over 5. All right, and now we have this one. You can see we've got lots of factoring to do. Number 10, we're going to divide x squared plus 13x plus 36 over x squared plus 14x plus 48 divided by x plus 4 squared over x squared plus 12x plus 35. Okay, so don't jump into the factoring yet. Remember that first step is you've got to rewrite. Keep the first fraction just like it is. X squared plus 13x plus 36 over x squared plus 14x plus 48. Change the division sign to a multiplication sign. Flip the second fraction. So I'm going to write it as x squared plus 12x plus 35, because that's going to go in the numerator now. And in the denominator, I have x plus 4 squared. All right, now it's time to do all our factoring. All right, the first numerator is x squared plus 13x plus 36. So a times c is 36. Factors of 36 that give me 13. That will be 9 times 4. So I'm going to split up b into a 9x and a 4x. Bring down my first term and my last term. And then I'll do my grouping. Pulling out an x, which leaves me with x plus 9. Pulling out a positive 4, which leaves me with x plus 9. They match. So I've got x plus 9 times x plus 4. All right, making progress. Got one of the parts done. X plus 9 times x plus 4. All right, now let's factor our next trinomial. X squared plus 12x plus 48. All right, so factors of 48 that give me 12. That would be, that give me 14. So that give me 14, that's going to be 6 times 8. 6 times 8 is 48, and 6 times 8 is, 6 plus 8 is 14, and I wrote it as 12. Okay, so I can split up b into a 6x and an 8x. Bring down the first term and the last term. All right, I'm making my groups. I'm going to pull out an x from the first group, which it leaves me with x plus 6. Bring down the plus. The GCF of the second group is 8, which leaves me with x plus 6. So I've got my x plus 6's that match. So x plus 6 times x plus 8. Okay, so we have one fraction done. Yay! Now it's time to go to our second fraction. All right, another split b problem. So I'm going to factor x squared plus 12x plus 35. So factors of 35 that give me 12, that's going to be 7 times 5. So I'm going to split up 12x into a 7x and a 5x. Bring down my first term and my last term. I do realize I'm going kind of fast through this split b, but this is a review skill for you, so hopefully you're okay with my speed. Making my groups, I'll pull out an x, which leaves me with x plus 7. Bring down the plus. I'll pull out a 5, which leaves me with x plus 7. So I've got x plus 7 times x plus 5. All right, so we've got x plus 7 times x plus 5. And then my last denominator says x plus 4 squared. Guess what? I don't have to factor that, but what I do need to do is write it out twice. So x plus 4 times x plus 4. Okay, it's all factored. Now we get the step of canceling, which feels good after you've done all that factoring. So what can I cancel? Well, I have 1x plus 4 can cancel out 1x plus 4. You can't do double dipping here. It's 1 for 1. And I have, wow. That is not a lot of canceling left, is there? Well, it's the squeeze step then. So now I'm ready to squeeze it all together. So my numerator will be x plus 9 times x plus 7 times x plus 5 all over x plus 6 times x plus 8 times x plus 4. And that is the quotient in simplified form. We weren't able to cancel much, but at least we did something. So that's the squeeze step. We just put it all together. You do not need to multiply it out. All right, again, the important thing to remember on this is you've got to do that rewrite step first. Don't jump into your factoring or you're going to mess things up because you might be canceling things incorrectly.